3.7 and 3.8, the equations of circles. This is part of my ultimate revision guide for further maths GCSE, the coordinate geometry section. Here we've got an index button that will take you back to the index of coordinate geometry, and any exam questions I've done on this topic I'll put links to in this bar here. Okay, so 3.7 is all about the equation of a circle, which is the simple equation x squared plus y squared is r squared, and that is a circle of centre 0, 0 with a radius of whatever this number is square rooted, so whatever r would be to square to make this number. So if this was 36 equals 36, the radius would be 6. If it was 20, it would be the square root of 20. And then we're going to go through the questions where we have the more advanced equation, where we have a minus x minus a all squared plus y minus b all squared is r squared, which is the same equation except for it's not centered on 0, 0, it's centered on a, b. So wherever the x coordinate is of the center, you take that away from x and square it, and whatever the b coordinate is, you take that away from y and square it, and then you have the radius squared again. So we're going to have some example questions. There's 3 on the standard equation with the center 0, 0, and then there's going to be 3 on the more advanced equation where the center is not 0, 0 necessarily. Okay, let's start with the first ones. Okay, so the equation of a circle is x squared plus y squared equals 2. Write down the coordinates of the centre of the circle. Because it's just x squared and y squared, that's a circle of centre 0, 0, or the origin. Write down the exact value of the radius of the circle. So this is equal to r squared, the radius squared. So the radius is going to be the square root of that, which is 2. And because we want the exact value, we don't write any decimal value. So this is sort of non-calculator type thing. We just leave it as the square root of 2. So that's just 1 mark questions there, just knowing the form of the equation and just putting the values in. Write down the equation of the circle, centre 0, 0 and radius 5. So that's, if it's 0, 0, it's just x squared plus y squared equals r squared, so 5 squared. So we just tidy that up and put x squared plus y squared is 25. So again, as long as we know the format of the equation for one on the 0, 0, it's really straightforward. Okay, question 3, possibly a bit trickier. We're given the equation of the circle, and we're told that the line y equals x minus 2 crosses a and b. We've got to work out the length of a to b. Okay, so to do that, we really need to work out the coordinate at this point and the coordinate at this point. And then we can use Pythagoras' theorem to work out the distance between them. So what we're going to do, this is essentially a pair of simultaneous equations where one's a quadratic. So we have x squared, y is equal to x minus 2, so we just replace that y with x minus 2, and that's all squared, and that's equal to 10. Multiply out the brackets, we get x squared, we're going to get another x squared, we're going to minus 2x, minus 2x is minus 4x, minus 2 squared is 4, and that's going to equal 10. So we've got 2x squared minus 4x plus 4 equals 10. Take the 10 over to this side, we get 2x squared minus 4x minus 10, 4 minus 10 is minus 6 equals 0. We can divide throughout by 2 to get x squared minus 2x minus 3 equals 0. And then we factorise this to get our two solutions, one for this point and one for this point. So can we factorise this simply? So we've got 3 and 1, it looks okay. So we have minus 3 and plus 1. That gives us minus 3x, and plus x is minus 2x, and minus 3, that's right. So x equals 3, or x equals minus 1. So this is minus 1, this is 3. And then we just got to work out the y values for that. So we know we're going to use the simple one, y equals x minus 2. So we've got x minus 2, 3 minus 2 is 1, and y equals minus 1 minus 2 is minus 3. So those are our two coordinates. So this one is minus 1, minus 3, and this one is 3, 1. So when we're trying to work out this, we're going across minus 1 to 3, which is 4, and then we're going up from minus 3 to 1, which is 4. So this is a right angle triangle, so the length AB is going to be the square root of 4 squared plus 4 squared. Pythagoras' theorem tells us that this squared equals this squared plus this squared. So we're going to have the square root of 16 plus 16, which is 32. 32 is not a square number, so we could simplify it. It doesn't say to do anything special here. We could leave it as root 32, but it's neater if we realise that this is just 16 times 2. And so we've got the square root of 16 times the square root of 2, which is 4 root 2. So those 3 questions used in the sort of standard equation. This one's actually more of a simultaneous equation, not actually using the circle formula much. Let's have a look at some of the harder ones where we could have the circle in any position. Okay, so this, remembering that it's x minus a squared plus y minus b squared equals r squared, where AB is the centre and r is the radius. Okay, so write down the coordinates of the centre of the circle. So we want minus a is a, so minus 3, so the x coordinate is 3, and we've got plus 2 here, but we want minus, so we actually need b to be minus 2. If we have minus minus 2, we get plus 2. So that gives us our coordinate of the centre. Write down the radius of the circle. Well, r squared is 16, so r equals 4. The radius is 4. Describe the transformation that maps this circle onto this circle, x squared plus y squared equals 16. Well, that's the same circle. It's just been moved from this position onto 0, 0. So we're going from 3 minus 2 to 0, 0. So we're moving it 3 to the left and 2 up. So we need to go minus 3, 2. So it's a translation. Minus 3, 2. Write down the equation of circle with this and radius this. So let's just put the numbers into the form, the general form. X minus a, which is minus 1, all squared, plus y minus b, all squared, equals the radius squared. So we have x minus minus 1 is plus 1 squared, and then we have y minus 4 squared equals 25. Okay, so that's the equation of that circle. The last question. Okay, so we've got the point P and the point Q. PQ is the diameter of a circle, so I've got a circle. P is minus 2, minus 3 down here somewhere. Minus 2, minus 3, and then Q is 4, 5 over here somewhere. And this is the diameter of the circle, so it goes through the centre. Okay, work out the equation of the circle. So to work out the equation of the circle, we need to know the radius. So we need to work out how far this is from here to here, and then halve it. And we need to know where the centre is, so we can find the midpoint of the diameter. That gives the centre, and that gives everything we need to know. So let's start with the radius. So using a bit of Pythagoras, we're going across from minus 2 to 4, which is 6, and then we're going up from minus 3 to 5, which is 8. So the radius, or well, the diameter, is equal to the square root of 6 squared plus 8 squared, and that's just a standard pairing, so that's 100. And the square root of 100 is 10. So the diameter is 10, so the radius is 5. So that tells us the r bit on our equation, so we're going to have it equal to 5 squared. So we're going to have x plus x minus something squared plus y minus something squared equals 5 squared. And this and this come from the coordinate of the centre. So the centre is just going to be halfway across and halfway up. So minus 2, well, it's going to 6 and 8, so we're going to go across 3, and we're going to go up 4. So we're going to cross 3 from minus 2, this is going to be 1, and going up 4 from minus 3 is going to be 1. So the centre is 1, 1, so we just take away 1, take away 1. So that's the equation of the circle. We should really square the 5, so we get x minus 1 all squared plus y minus 1 all squared equals 25. would be the equation of that circle. So hopefully that's helped you with the circles. Pretty standard when you get used to them.